All right, well, so starting off where the last movie ended, we know that our initial velocity of this 15 seconds, so right here, is going to be 20 because that was our final velocity over here. Okay, so so from 10 to 15 seconds, our initial velocity is going to be this 20 meters per second. And so we want to know what is going to be our velocity at the end of this 15-second interval. So our beginning velocity is this 20. What is our end velocity after 15? So we're going to say our beginning velocity we know is 20 meters per second. V equals 20 plus, our acceleration is 0 this time from 10 to 15 seconds. So you're going to say 0 times 5 is going to equal 20 meters per second. So we're going to write 20 meters per second. Okay, so now we want to know what is our final velocity at this 20 seconds right here. And so what we're going to do is we're going to say our V naught is going to equal, again, this 20 meters per second, because that was our final velocity at 15, from 10 to 15, that was our final velocity. So now it's our initial velocity to find our final velocity at 20. And so you're going to say V equals 20, because that's our initial velocity, plus, now our acceleration is this -4 times, can't see that, times the 5. And so we get 20 plus a -20, which equals 0 meters per second. So we're going to write that down in our little box right there that it tells us. So now what we're about to do is we're going to graph this. So we see that from 0 to 5, it is going to be this 0 meters per second. So we are going to have to draw a straight line from here to here because it is just 0 meters per second, because we started at 0 and we ended at 0 at 5 seconds. So we started at 0 and then we ended at 0 at 5. And so, but now, at 5, in the beginning, our initial velocity is 0, but then at 10 seconds, it's now 20 meters per second. So down here, we can now add a dot right here. So at 10 seconds, our final velocity is 20 meters per second. Then look, from 10 to 15 seconds, it is still going to be 20 meters per second. But then at the end of 20 seconds, it is going to be at 0 meters per second. So this is what our next graph is going to look like. So now they want us to determine the displacement x of the elevator above the starting point at each 5-second interval. So now we're going to take this graph and turn it into a displacement graph. All right. So let's go ahead and do our work on this next piece of paper. So I'll just keep my graph right here for you guys. And so to do this, we're going to say, we know that really we could just look at the area under the graph. We could do that. So when we do that, we see that right here, we don't really go any distance at all. So from 0 to 5 seconds, we've gone 0 meters. All right, but then from 5 to 10 seconds, we see that we have gone a distance of so this is going to be from 5 to 10 seconds. We have gone a distance of 1/2. So, because it's a triangle, all right, so you guys see this is the area that we're looking for because it's 5 to 10. So 1/2, our base, which is going to be 5 because it's 5 to 10, times our height, which is our 20. And so we end up with, so 1/2 times 20 is 10. We end up with 50 meters. Oops, not meters per second, just meters, right? And so now let's look from 10 to 15. So 10 to 15, again, we're going to look at this area. But this time we don't have to do the triangle. It's just a base, which is 5, times our height, which is 20. So we end up with 100 meters. All right, but at the end of 15 seconds, we haven't just gone 100 meters. We've gone 100 plus this 50, because when we get to this 15 point, we've gone this whole entire way. So we're going to have to say 100 plus this 50 meters, which gives us 150 meters. All right, so then our next interval is 15 to 20 seconds, and we see that this is again another triangle, so we're going to have to do our 1/2 times our base, which is again our 5, times our height, which is the 20, and so we end up with another 50 meters, but it's not just 50 because you see at the end of 20 we've gone this whole distance right here. So we're going to add this 50 to 150, forgot my units right there, and we end up with a total distance of 200 meters. Now let's graph that, and well, first we probably should put this on our the table, which they tell us to do. So we want to get all the points possible. And so we see that from 0 to 5 seconds we have gone 0 meters. So we're just going to do a little 0 like that. Then at the 10 seconds we have gone 50 meters. But you see that we have accelerated those 10 seconds. So this is going to end up looking like a curved line up because we have accelerated. We've accelerated because we see that there's a positive slope right here. And then from 10 to 15 seconds, we see that we've gone a constant velocity. And so that's going to look like a straight line up. And now we're at 150. So at the end of 15 seconds, we're at 115 or 150. So that's going to be a straight line up like that. And then to get to 200, which is where we end up at 20 seconds, we see that we are decelerating. And that's going to look like this other kind of curve, but it's like the upside down version of that. So that is what your graph will end up looking like. I hope you enjoyed this video.